You'll notice that my walks are a bit slow now because we're nearly at the end. As much as I've enjoyed all of our speakers today, it's always bittersweet because it means that we're finishing and there's only one more speaker left. So the only thing I did want to remind you guys is if anybody did grab or made a squishy on their tables, just to get it over to Vicky over on the Make a Squishy stand, because she will be reviewing and we will be announcing the winner after the Q&A session. So if you do have one, just make sure to hand it over so it can be judged and you might be in with a chance of winning a really cool prize, okay? And hopefully you guys got creative as much as possible. And I'm also trying to fill in the time while the next speaker gets mic'd up. So I'll just keep doing that. No, I'm just messing. But I do hope that you guys did enjoy the speakers. I saw a lot of you taking notes. And one of the things I've seen, the energy as well did rise up today. So I know you're tired. I know you're kind of like, girl, get off the stage so we can do the after party. We will, okay? We will. But we have one more speaker. And it couldn't be a better speaker to close out ShipItCon 2023. So to close it out today, we have Luciano Mammino, who is an AWS serverless hero, who shares a birth date with Super Mario's release in Europe. Coincidentally, his favorite game as well. I think he was the third Super Mario brother who was dropped, but look, that's just my thing. He's been coding since before puberty, leading him to be a senior architect at Fort Worth, where he helps companies to get the best of the cloud, AWS, and serverless. He loves the full stack web, Node.js, and serverless, and co-authored Node.js design patterns. So guys, give a huge round of applause for our final speaker for ShipItCon 2023.
Hello everyone. Thank you, CK, for the lovely introduction. Let's see if it works. Yeah, okay, so you already got all the introduction, so I'm just going to say very quickly that I have all my contacts here. You can just either scan the QR code or go to this link in case you want to reach out later, especially if you want to give me any feedback about the book. I know this is not going to be about Node.js, but you know, maybe there are Node.js people here. All right, let me tell you a little bit about Fortiorem. We are a consulting company specialized on AWS and serverless. With our customers, we have done many projects, especially around the realm of cloud migrations, training, cloud enablement. We built a few interesting high-performance computing applications based on serverless. We even have a case study published with AWS about that. And we have also been working in projects where we try to reduce the cloud cost. So if any of this stuff sounds interesting to you, reach out to us. There is another QR code with our contacts, or there are lots of people from Fortiorem around, so feel free to talk with us. Now, we also have a podcast because, of course, these days you have to have a podcast. So myself and Owen Shanagy, who is the CTO of Fortiorem, we publish an episode every week. It's called awsbytes.com. We do this funny artwork, so hopefully you like that. But I hope that more importantly, you will like the content that we try to share every week. Okay, let's talk about a real serverless case study. So you build serverless applications, and it's funny to see that you start very small because sometimes you just need one Lambda, maybe a few policies, maybe an S3 bucket, an API gateway, and that's it. But then very quickly you start to grow the application, you add more and more components, and when you are done with the first release, you realize, wow, there are already like hundreds of resources in this stack. And of course, the more you keep investing into this approach, you create more stacks and you end up with hundreds and hundreds and even thousands of resources splitted by services and stacks. And now the questions that you may start to wonder about, especially if you are starting to go to production, are things like, okay, is this architecture really good enough? Or how do we find issues when we are in production before our users will start to see these issues and complain? How can we discover edge cases that maybe we haven't thought about? So these are all the kind of questions that you should be asking yourself. And one of the tools that can answer some of these questions at least is observability. And today we heard a lot about observability, so I think you have a good understanding of what's a definition of it. But a definition that I really like is when you can tell how a system is behaving just by looking at the output of the system. And by output, I mean in general things like structured logs, tracing, metrics, and alarms. So you don't need to look at the code or do a debugging session to understand where are the problems. If you have done a good job in terms of observability, just by looking at in these different areas, you should be getting enough information to be able to understand what's the problem and figure out what can be a good resolution for that particular problem. Now, let's say that we have built an application and we want to see, did we do a good job with the observability? What could be one way to try to answer that question? And recently, it happened to us that we built an application and we were doing lots of stuff around observability, but we asked ourselves, how do we even test our observability? And the idea that we had is, okay, because we built a bunch of end-to-end and integration tests, maybe one way of trying to understand what is our observability posture is maybe we can run that end-to-end test in a loop multiple times just to see what happens. And the idea is that if we do that, if we have written very good tests, we should be exercising different APIs and the more common use cases or user flows. For instance, login, different CRUD applications. Maybe it's an e-commerce, so you can imagine a user is logging in, is selecting a product, putting that product in the cart, completing the purchase. So if you have this kind of test and you can run them multiple times, you are probably exercising different parts of your application just to see what is the result. So we did all of that, and funny enough, after 10 or 15 minutes, we start to get a lot of alarms. And we get our alarms in Slack, in this particular case, and you start to see a bunch of things popping up everywhere. And that can be a little bit frustrating and confusing. So the first thing that you should do is don't get overwhelmed. Just try to figure out bit by bit what's going on, and you try to build your own mental model for what's possibly happening in the system just by looking at different events and trying to create a story between them. So in this particular case, what we saw is that there were issues coming from API Gateway. We saw alarms, 500 errors happening. We also saw Lambda function issues. We saw errors. We saw that the duration of Lambda was increasing. We saw errors in DynamoDB. We saw that certain requests were being throttled. So if we look at all these things and we try to create a storyline, we can put things in this particular order. And even better, if we try to read this storyline in reverse, what we can tell is that probably what's going on is that we are getting throttled at DynamoDB level, which is probably causing the AWS SDK to retry multiple times because there is a throttle, the system is going to wait a little bit and try again, which increments the duration of the Lambda execution to the point that maybe there is a timeout. And that timeout, from the API Gateway perspective, is just the backend is failing, so this is a 502 error. Now we have this story which kind of makes sense, but the next question is, we are making this story up just based on alarms that we are seeing. How do we really validate that this story is the real one? And there are a few things that we can do using observability. So we can check what is the cause of these timeouts by looking at the logs or by looking at the metrics. We can check what are the Lambda errors, again, by looking in the Lambda logs. We can identify the source of 500 errors by looking in API Gateway or using tools like tracing, for instance, using X-ray. And we can also check in DynamoDB, there are dashboards and metrics that can tell us why are we getting throttled, when are we getting throttled, how often are we getting throttled. So all this information is useful to try to validate if this storyline actually makes sense. So the first thing that we did is we have a dashboard, so let's go and just look at this dashboard. And this dashboard is a little bit confusing. It's like a single pane of glass where you pretty much have everything that is important. But there is a lot of noise. So the one thing that you can do here is try to identify correlations. For instance, one thing that we noticed here is that just by comparing these two graphs, that basically you have when you get more throttling in DynamoDB, this is also when we get increased duration in our Lambda execution. So probably there is some correlation there. So these kind of dashboards are really useful to identify which things are happening in your system and which different resources are being affected by particular events. But of course, they don't give us a lot of details. It's just a starting point to narrow down the focus on resources that can be affected. So the next thing that we can do is let's check the logs. And if you use CloudWatch logs inside, you actually have a very powerful query language to investigate and try to extrapolate information from the data that you write in your logs. And here, for instance, we have 2 queries. The first one is just trying to figure out how many timeouts are happening and which ones are those timeouts. This is the first query at the top. The other one is trying to create buckets of duration, execution duration of Lambda functions, trying to figure out how many executions are within 0 and 1 seconds up until 6 seconds, which is our timeout for this particular Lambda. And you can see that the majority of the requests is actually fine. We only had 4 timeouts, but nonetheless, we want to understand why are we having these 4 timeouts. There might be actually an important issue there, and it might affect some users, so it's something that we really need to understand and probably address. Another way that we can look at the system is by looking at tracing tools. For instance, this is a view from X-ray, and this is also a little bit confusing. It's kind of a service map that you can get just by configuring X-ray and tracking the interaction between different resources. And this is, again, just a good way to try to visualize how resources are connected together. If there is an error somewhere, what else can be affected by that particular error? But the cool thing about tools like X-ray is that you can have a visibility also at the request level. So for one particular request, you can see exactly which systems are involved, which resources are involved, and if there was an error, where was that error, what was the duration of that particular execution for every single entity that was involved in that particular request. So if we look at the 502 error for one particular request that was giving this error, what we see is that API gateway took a little bit more than 6 seconds, which we know is our timeout, and that's why it's failing. We also see that the Lambda is taking 6 seconds, so we understand, okay, the Lambda is timing out, therefore we are getting this API gateway error. But one thing that is a little bit confusing is that we were expecting to see DynamoDB in this picture, and it's not there. So what's going on here? This is a little bit confusing. So we can go and check in DynamoDB to try to confirm our assumptions. And what we notice here is that we allocated a write capacity unit of 2, and without going into too much detail, is basically we are saying we are going to write only so much data for a certain amount of time, and we assume the unit 2 is going to be fine, when in reality, by running these tests, we are basically stressing the system more than we expected. So we are going over this capacity, and that's why we are getting throttled. So we can see that when we have spikes, these spikes are correlated to the throttle events. So that kind of confirms our assumption. And we also understand that the reason why we didn't see DynamoDB is because we didn't really get to call DynamoDB because we were getting throttled before at the API level. So another thing that we realized when doing this investigation is that there is even a 500 error, and this is something that we didn't expect. We didn't even notice alarms before for this. So just by doing this investigation, we actually started to find more problems that we actually anticipated. And if we look deeply into this particular request, what we can see is that in this case, this is an actual system error. So API gateway is returning a response very quickly, and this is a definitive error. The Lambda was being executed very quickly, and the error is actually in DynamoDB. And if we look at the logs, the error is basically telling us that this is a validation error, because specifically what's going on here is that we were trying to update a record that was already deleted. So this is an actual bug somewhere in our system, and we need to figure out why this is happening when we run this particular set of tests. So this is kind of our conclusion after looking at all this data and all this evidence. We had actually 3 different problems that were kind of together working and creating all this noise. The first one is that we provision DynamoDB with very low write capacity. So there are different solutions there. For instance, you could just increase the capacity if you have something very predictable. Or another alternative is you can switch to pay-per request or on-demand mode, where basically DynamoDB is going to automatically scale and you have a different pricing model. So that's what we did in this particular case to try to remove that particular issue. For what concerns the 502 errors, this is something that you cannot really avoid because every resource in AWS, there are limits or quotas, and you need to learn exactly how to work with them. So sometimes you're going to get throttling. So it's more how do you handle those cases when you get throttling. And in this particular case, because we are in a Lambda and this Lambda is backing an API request, we want to respond as fast as possible. So even the retry is something that we should do, but keep them very quick. So what we did here, we reduced the back off and we reduced the number of retries. So if we cannot actually get that information in 350 milliseconds, we are just going to assume this request is going to fail, but at least we get a very clear error on why that request is failed. We are not going to get a generic, this Lambda timed out. And then for the 500 errors, that was an issue with our API testing, because basically the testing was not built to be executed concurrently multiple times. We were creating records with a very specific ID, and sometimes if you were running 2 tests, one test might be deleting something that the other test was trying to use. So that was just an issue with our testing, and basically we built a better ID system that will be unique to that execution, and that fixed the problem with the 500. Okay, so now if we look at the before and after, the difference is that here we have a very clear capacity line. You can see that at the 2 level there is an horizontal line, and you can see that every time we were going over that line, this is where we were getting the throttle events, which is the red line in the graph. But now, because we removed that hard capacity unit and we have a kind of an elastic scaling system, it doesn't really matter, like you don't get as many throttle events and the capacity can scale automatically. So what we have learned so far is that just by having good observability, we were able to identify, understand, and fix errors quite quickly without having to debug the code locally. And basically, we were able to tell what was happening in the system just by looking at the output of that system. And this is only possible because we spend the time to configure observability in AWS in advance. Now, when it comes to observability, in AWS you have CloudWatch, which is the go-to default tool. It contains most of the tooling you need for observability, like logs, metrics, dashboards, alarms, and even more. But of course, there are other tools that you can easily integrate in AWS. So of course, I'm going to be talking more about CloudWatch because this is what we use the most. But I think everything I'm going to say is going to be applicable for other tools as well. Now, if you use CloudWatch, it's actually a pretty cool tool, and out of the box gives you some interesting things. So you get all these different things like logs, metrics, as I said, and also metrics are generated by default. Like you don't need to configure anything. There are a series of metrics that just by using specific services, you get out of the box. For instance, if you get an EC2 instance, you will be able to see how much memory or CPU is using at any time without having to explicitly configure metrics for those things. Then there are also lots of dashboards, but there is a little bit of a problem there, that these dashboards are something that you get per resource, so you need to go to the specific page in the AWS console, for instance, of a given Lambda, switch to the monitoring tab just to see dashboards there. Generally, you want to think of dashboards in terms of an application or a stack, and you don't get anything out of the box for a specific stack. And the other problem is that you don't get any alarm out of the box. So when it comes to alarms, you have to configure all of that yourself. And configuring alarms is something that, of course, you can do manually, going in the console, but I wouldn't recommend that. I would recommend always to do infrastructure as code, especially for production projects. And if you want to do infrastructure as code for alarms, you can see that it gets very painful. You need to write all this JSON, which is deeply nested, and nobody wants to write the stuff. And even if you want to, probably you're going to get something wrong unless you spend a lot of time testing all this stuff. So how do we try to get the best from CloudWatch? There are things that we get out of the box, but other things we need to do some work. What is a good strategy to do that? So first of all, you need to research and understand the available metrics. You need to decide what are good thresholds for your business, what are the best metrics that you should be observing. Then you need to write infrastructure as code to create alarms and dashboards. And of course, this is a process that never ends. Like when you develop new features or when you change something in the system, you need to make sure that you are also updating all these things. Like your observability is going to evolve as your application evolves. And then if you build multiple applications, the same process applies. So most of the time, you're going to find yourself copy-pasting kind of starting templates, applying them to other projects, and then how do you keep changes in sync? It can be a little bit daunting. So it's a lot of work. If you do it, I promise it's going to pay off, but nonetheless, it's a lot of work. And to be fair, you are not alone. There is a lot of best practices out there that you can use. And for instance, there is the serverless application lens from the well-architected framework that gives you lots of insights on what are the things that could be more important for your application. Again, it's good guidance and it's great to have this kind of resources, but it's more work that we need to do. We need to read these resources, understand how they apply to our specific context, and then put them into practice. So there is an idea that we started to have at Fortiorem after we configure more and more projects and done all this observability over and over. And we started to think, okay, every time we build a new project, we do infrastructure as code. So that means that there is a place in the project where everything is very well described. All the resources that exist in this project are there, and they are written in such a way that machine can parse it. So that means we can build automation around that. So the idea that we had at some point is, can we create a process that takes all this infrastructure as code as input and as output creates a baseline for all the observability best practices that we know and we want to apply to every project. And from this idea, SLIC Watch was created. And SLIC Watch is an open source project that basically what it does, it takes your CloudFormation, and that CloudFormation can come from different tools, could be either serverless framework, SAM, or CDK, and is able to sit in between your original CloudFormation and the deployment process. And what it's going to do is going to take the original CloudFormation produced by your tooling of choice, look into that, understand all the resources that are available, and then it's going to expand that JSON into an even bigger JSON containing a bunch of alarms and dashboards that are built out of the box for you. Then you deploy, and you are basically deploying your stack, which has been enhanced with out-of-the-box alarms and dashboards without you having to write all the stuff by hand yourself. Now, I have to put a few caveats there, because you're probably having some questions at this point, also based on the previous talks you might have seen today. And the first caveat is that this is not AI-driven, so there is no magic large language model or anything like that. This is very predictable and very dumb rules, like if you use SQS, you're going to get this kind of alarms. If you use Lambda, you're going to get this kind of alarms and dashboards. So that's the first disclaimer. The second disclaimer is this is not removing you having to think about observability. This is just solving kind of the 80% of the simple stuff, but you still have to do the hard work of that 20%, which is all the metrics that are very specific to your business, all the alarms that are very specific to your business. You still need to do that effort yourself. So SLIC Watch is something that can help you a lot and save you a lot of time, but it doesn't remove having to think about observability. So just keep that in mind as we go through SLIC Watch. So just to give you an idea of how much stuff SLIC Watch is saving you, this is an example of a moderately big project. I think there are a few hundred resources in it, between DynamoDB tables, Lambda functions, step functions, an API gateway, and more. Actually, we have this example in a repository if you want to check it out later. And here we can see the SLIC Watch generated more than 2,000 lines of code of JSON that you didn't have to write yourself. And these are all alarms and dashboards. But the more interesting part is actually dashboards, because a dashboard in the CloudFormation JSON is something very nasty where you have to specify a JSON encoded inside a JSON string. So definitely something that you don't want to write yourself by hand. And it can get very long. It's like one line there that is like 17,000 characters. So definitely you want to use tooling to help you writing all this stuff. So now let's deploy a real application. And this can be a moderately complicated application with multiple resources. Let's say that we deployed it, we go to the AWS console, and we want to see what are my alarms. And this is what you're going to get by default. There is no alarm. AWS doesn't give you anything. You are on your own. Go figure it out. So now you know about SLIC Watch. So let's say that we want to use SLIC Watch to get a baseline of good default alarms that we can start with. If you use the serverless framework, SLIC Watch, you can use it as a plugin. So you just need to say, install this plugin. And if you ever use the serverless framework, the way you enable plugins is just by going to the serverless YAML, and in the plugin section, you have lines saying all the plugins that you want to use. So we just need to enable this particular plugin. After you do that, you just need to deploy. And after you deploy, you go back to AWS, go in the alarm section, and you can see already that there is a lot of stuff that has been created for you out of the box. And just to give you an example of the kind of things that you will get, which are coming from the best practices that we saw before from all the tools like the serverless lens. For instance, if you're using an API gateway, out of the box, you are going to get an alarm that is going to monitor for increased 400 type of errors. And this is actually something that might seem unnecessary, but if you ever built something like a mobile application where you might have an API on the back end and a mobile application running in a client, sometimes you might be updating the API and maybe change some validation rules, and then you don't realize that there are still people out there that might be using an outdated version of the application, so you might end up sending requests to the backend, and those requests are not compliant anymore. So by having this kind of observability tool in place, you might realize straight away, wow, we are getting an increased rate of 400 errors after the last deploy, so probably we did something that wasn't really backward compatible. Maybe we should roll back and revisit our latest change and maybe do something different. But if you didn't have this kind of observability, your users will get a lot of errors, and you will need to rely on a user reporting that particular error. Other examples are, for instance, if you use SQS, you might have a spike of activity on your own service, and maybe the kind of workers that you allocated to process the jobs from the queue are not going to be able to keep up with that spike, and you are going to be serving those jobs later and later and slowing down the processing more and more. So by default, if you use SQS, with SLIC Watch, you're going to get alarms that will inform you if you are lagging behind in processing jobs from a queue. And that's something that you didn't need to configure by hand. Now, another thing that you are going to get is dashboards. By default, SLIC Watch is going to create a dashboard with all the different things that are relevant from your stack. It might be a little bit messy, and there is probably work to do to make this a little bit more usable. But this is already a good place to start where you want to see correlation between possible events that are happening in one place and how they might be affecting other places in your system. Finally, another interesting thing is that every alarm can be sent to an SNS topic if you configure that. And when you have alarms going to SNS, that enables a bunch of integrations. For instance, you can use AWS chatbot to send the alarms to Slack, as we saw before, or maybe Microsoft Teams, or even other chat system. Or you can even integrate with things like Ops Genie. So if you have people on call, or you manage like rotations of people on call, you can send the alarms directly to that system, and that can trigger an entire human intervention process where you can track exactly that issue and trying to resolve that issue. Now, everything that I mentioned so far, I didn't show any configuration, because by default there is a configuration that should work for most of the cases. But of course you can configure everything. You might enable or disable alarms that you don't like. Even sometimes for costing reason, maybe there are alarms that you don't really care about, so you can reduce the cost without provisioning those alarms. You can change the threshold, so if you want to have different thresholds, you can do all of that. And the way you do that is just by editing the YAML, in this case, in the serverless.yaml. So just to recap what is the process, the first step, and this is optional, you might want to create an SNS topic. Then you install SLIC Watch as a serverless plugin. You update the serverless YAML to enable the plugin. You might want to write some custom configuration to configure different things. You do another SLS deploy, and then you get all this observability built in. As I said, we have a repository with the entire code of SLIC Watch. It's a monorepo, and one of the things you find in the monorepo is an example project contains a bunch of different resources, so you can try to enable and disable SLIC Watch there, play with different configuration, and see what happens. And you might be wondering, what if I use other tools? Well, SLIC Watch today supports CloudFormation, so everything that works with CloudFormation is something you can use. With serverless framework, it's a little bit easier because you just install the plugin with npm and you are ready to go. When you use bare-bone CloudFormation, you need to also have a transformer in your own account. So we have that transformer available for you in serverless application repository, but it's still something that you need to install into your own account. If you check the README on how to do all of that, that makes it easier to use SLIC Watch with CDK or SAM or with barebone CloudFormation. Now, what if you want to use Terraform or Pulumi? We'd love to support all of that, but you can imagine it's a lot of work. So this is an open source project, so if you want to do something like this for Terraform or Pulumi, you are more than welcome to contribute. We also have a roadmap, so we know that there are things that are missing or things that can be improved, and we keep track of all these things in the repository. So if you want to contribute but you don't know where to start, definitely check out what we have already available in the repository. Or if you have ideas or proposals for features that are missing there, of course, you are more than welcome to submit a PR or open an issue. So just to recap and wrap up, when you build event-driven systems like serverless systems, observability is a must. It's pretty much impossible to replicate that system in your local development machine. So when there is an issue, you shouldn't be even trying to do that. You need to rely on observability to be able to find the problems, understand what's going on, and figure out how to fix those problems. So if you do good observability, it's a big investment, but it will pay off big time. And CloudWatch is a tool that you can use in AWS to do all of these things, but it takes a while to get used to it. It takes a while to configure everything as infrastructure as code. So a good place to start to have a decent baseline is to use a tool like SLIC Watch. They didn't like SLIC Watch. So yeah, if you think this is interesting, try it out, give us some feedback, and it's an open source project, so everyone can contribute to make it better. One last thing, all the slides are available online, so you can scan the QR code or go to the link that you see there. You will find all my contacts, you will find all the details and all the links, so please do that if anything I said was somewhat interesting. Thank you very much.
And that is the end of our speakers for ShipItCon 2023. Guys, thank you so much for joining us today. We will be moving on to the Q&A portion just in a few minutes. I just have two announcements.